managing staffing levels. If I have two types of costs that I will consider, cost of capacity, which is related to the number of workers or customer service representatives that I hire, and that on the other hand, I have cost of waiting or cost of line charges in total um, that I pay because this is maybe a toll-free number. Now, of course, the average service time, if it is, let's say, in this example, 90 seconds, I will always pay the cost of line charge for 90 seconds. But the cost of waiting, right, the TQ, I might if the waiting time is shorter, I will have smaller charge for the time of waiting. So here I'm considering an example as before with 79 calls arriving per 15 minutes or per 900 seconds. So I have one call every 11.39 seconds. Coefficient of variation is 1 for inter-arrivals. Processing time is 90 seconds, and coefficient of variation for processing time is 1.33. And I also have the data for the cost, right? I'm paying $10 per hour for my customer service representatives, and the waiting line cost or waiting cost is $3 per hour. Notice I will actually calculate this cost $3 per hour for the full connection, so for the flow time T, not just TQ, right? Not just for waiting. The question is, how many servers should I have? So what I will do is I will calculate the total cost of labor related to labor and related to waiting, or actually connection cost, right? Depending on the number of servers. So if you recall, we did already calculate for m equal 10, we calculated the utilization was 79%, right? Here I'm just putting a utilization factor to show you how rapidly it is changing when we decrease the number of servers to 8, right? And then we have the average waiting time, which, if you recall, was almost 25 seconds in the case of 10 servers. I want you to see that when we decrease it to 9 and then to 10, the utilization to 8, utilization at 8 becomes 99%. That's almost 100%, right? And notice utilization factor becomes a very large number, 78, much larger than 2. And of course, you can see it affecting the average waiting time. Instead of 25 seconds, it becomes 1,221 seconds, which is more than 20 minutes now. And remember, this is just an average waiting time. If an average waiting time is 20 minutes, you could expect some customers would be waiting even 1 hour or more. And of course, this is probably not a very good solution to even consider. But we can still try and evaluate the cost implications of this. So right on the other hand, we can increase the number of servers to 11, 12, and more even. And so, of course, utilization is dropping, and you can see the waiting time becomes very small. This is on average 5.5 seconds with 12 servers. So how do I calculate cost of direct labor per call? Notice that this is the same kind of cost we calculated in the assembly line, where we said, what is the cost of direct labor per unit produced? And right, in this case, the unit that we produce is the call we answer. So it's right, we're not manufacturing, we're providing a service, and the unit of service is one call or one customer that is served. So cost of direct labor, as before, we can calculate it as what are the salaries that we pay per unit of time, let's say per day, and what is the number of calls that we answer per day or per hour, whatever time frame you like. If we do this division, of course, the number of calls that we serve per unit of time is constant, because we know there is, the flow rate is one call every 11.39 seconds, and it doesn't change when we change the number of workers, right? So the denominator in this calculation will be constant, and the numerator will be just the salaries. In the first case, salaries of 8 workers, salaries of 9 workers, 10 workers, and so on. So this is basically increasing proportionately to the number of servers. This column, however, is different, right? This is the cost of line charges. And in this case, I calculated the costs related to both waiting and processing. So basically, this is cost for the call spending T time units in the system, including TQ of waiting and 90 seconds of processing P, right? So notice, right, when we have this case, waiting is almost 20, a little bit more than 20 minutes, and there's another minute and a half of processing, the line charges in total will be roughly 1/3, right? It's over 20 minutes. If $3 per hour, that means we will be paying over $1 for every call just because of line charges for waiting and service time. If the waiting drops significantly, so do the line charges. So this becomes 13 cents, 13 and a half. Here it is 9.5 cents roughly, and so on. And they become much smaller. And of course, the decrease becomes almost insignificant because the waiting time is already very tiny compared to the 90 seconds of service. So this cost is mostly for the 90 seconds of service, which we cannot avoid. So the interesting thing to realize is that the line charge cost is per call, and cost of direct labor is also calculated as dollars per call. So both of those costs are costs dollars per call, and we can add them. So we can see here as the sum of those costs. And you will notice that there is a kind of convex function here, where we start from a very high value, rapidly decreasing, $1.34, 42 cents, 41 cents, and then it starts increasing, 43 cents, 46 cents, and probably it will increase even more. The reason for this increase is that the cost of direct labor would continue increasing at the same rate, while this cost will probably almost stop decreasing because the waiting time becomes almost zero on average. So here, basically, we should expect further increase. And if we are interested in minimizing the total cost of providing the capacity and paying for the line charges, then this is the optimal level. So we should choose 10 servers. However, some managers might want to introduce larger number of servers, like 11, 12 or more, if your consideration is not just the cost, right? You might want to increase the cost somewhat in order to further reduce waiting time. Maybe 25 seconds average waiting time is still not satisfactory, right? So this is also a reasonable solution. It actually doesn't make any sense to reduce the number of servers here because it is more expensive, and at the same time, it will provide a very bad service to your customers. So, of course, this kind of analysis can be done for every time interval for which we do analysis. Remember when we talked about whether the process has seasonality or is stationary, we said divide the timeline into time periods in which the process, the system is stationary, the arrival and service times behave like stationary processes. And so if we do this, we can come up for any time period, we can come up with a desired, these green boxes are like desired number of servers that we would like to have. And this is kind of showing you overlapping with the blue line here is number of customers arriving per 15 minutes that we expect, right? So if we do this analysis for any time interval, we can come up with the desired number of servers, right? And then we can try and come up with, hire enough workers to cover the desired number. In practice, of course, it is quite a complex problem because workers don't want to come just for 2 hours and then leave and then come back later for 1 more hour. You need to give them long enough work periods. You need to also think about breaks for operators. Nevertheless, this kind of analysis is a good starting point, and then coming up with the staffing plan is another task that could be somehow solved with minimizing the cost of actually hiring workers that will be providing the required, the desired service.